Hello friends, welcome to Akul Mac Business Channel, and in the multiverse section today we are going to analyze how we have such large black holes in the center of our Milky Way, because the universe is only 14 billion years old, roughly 13.8 to 14 billion years old, and this time is not sufficient for forming these billion solar masses black hole, and that's a mystery. There are new developments, and we are going to analyze and discuss those in today's program. Well, the mystery of very large black holes was first, found out by the discovery of something called quasars. Now, quasars are very large objects which are found at the very edge of visible universe. They are very energetic. They have something called active galactical nuclei. That means a very large black hole in the middle of these galaxies, and these galaxies are rotating very fast, and the black hole which is in the middle is also eating a lot of gas which are present in these galaxies, and emitting so much light that the central black hole is overshining the rest of the galaxy. Normally, the central black hole is not at all visible. And I mean, if we look around the galaxy, we actually like to see the galaxy in a very nice spiral format. But in case of quasars, the center outshines the entire galaxy. That means the center of the large black hole is very active, is gobbling a lot of material and also emitting a lot of energy. So far, we have seen these objects, very energetic objects, about 200 if we have counted them, and most of them are in the outer regions of the space. When we say outer region, they are so far that the light itself takes about 13 billion years from these very powerful objects known as quasars to reach us. That means they are basically formed in the early part of the universe, when the universe was still forming, and so the quasars that we see today are very far off, very energetic objects, and at the same time formed very early. Now the question is how on earth we had these processes where such large black holes can be formed. Usually the black holes are formed when a large star collapses, and it will form a small black hole which will not be more than 2 to 3 solar masses. And yet the center of the galaxy, even in our galaxy, there is the large black hole which is 400 million solar masses. It is the estimated weight, which is way beyond a normal black hole. These are very large monsters, and every galaxy has one large super massive black hole, or some of the large galaxies have ultra massive black holes in the middle, which weighs as much as billions times, multi-billion times the mass of the sun. So that has been a big mystery how these large black holes were formed. And if we actually understand a little bit more about these ultra massive black hole, that in order for these black holes to naturally absorb a lot of material and grow large, the time is not sufficient. The time it takes, because in universe, from our point of view, our human scale, the things moves very slowly. So for all these smaller black holes which are like 2 to 3 solar masses, and then gobble all the material and become a billion solar mass type black hole, the time of 13 billion years is not sufficient for a black hole to absorb and then rapidly grow to this size. So to explain this phenomena, our physics is not giving enough input or enough evidence or enough processes to demonstrate that how these very large black holes which exist in the middle of the uh, galaxy can grow so large. So that is the mystery. And but recently scientists conducted an experiment using a certain simulator, and they are able to throw some light on the existence of or the processes which are involved in creating these large black holes. Now, when we talk about these large black holes, the paradox itself, it creates a lot of paradoxes. The paradox itself is that the material which is used by these black holes to absorb and consequently increase in size, uh, when the black hole is formed, it starts pushing things away because the energy will then start a process. The material which is rotating around the black hole will create heat, and that heat will basically expand. So what happens is when the black hole is formed, the material which is outside generate heat, and then it start preventing any further material to fall under the black hole. So formation of black hole itself creates a paradox where the material, the black hole will not be in a position to gobble up lot of material by virtue of its property. So that is a paradox, and there are other paradox which we are not discussing in today's video. But I think we are limiting only how a black hole can become so large by gobbling, whereas when the black hole itself will create an environment which will stop the feeding frenzy of the black hole. So that is one of the paradox, and the scientists were searching answers for this paradox for many years. And to do this kind of analysis, uh, there are simulators which have been designed. Now, what are these simulators? The simulators are uh, very powerful computers which will basically generate the conditions which would have prevailed at the in the early part of the universe when the universe was forming. And typically, lot of calculations are used using the supercomputer, and the supercomputer then use the laws of physics which are fed into the program and then simulate the early part of the universe. So scientists have used one of these very high-tech simulator, and they have been doing a lot of research on that, and the different conditions are created, and there are a lot of what if scenarios, that if it is conditions were like this, then what would be the outcome, etc. So there is, this is using simulator, a pure research work which scientists have been able to do, and they have found some very surprising facts. And one of the surprising facts is that when initially when the matter started forming in the early part of the universe, the temperature was cool. The gas was actually cool, not hot, because the stars were very few stars were there, and most of the gas which was created, most of the matter was actually in the cool category. That was only few 1 or 2 Kelvin more than the mean temperature of the universe. So it used to be a very cool gas, not hot. The temperature of the gas will increase only when there are a lot of star formation happening. But at that point in time, the stars were very few, and they were very far apart, and that could not influence enough to increase the temperature of the general temperature of the universe. So most of the gas that existed was cool in nature, and because the temperature of this gas was cool, yet it provided a lot of gravity because of the existence of the matter, and there was existence of the dark matter also, which is also very strange phenomena. We don't know the answers for dark matter, but the whole concoction of dark matter and the cool gas created a cool universe, a colder universe, and most of the material got accumulated. As you can see in this picture, which I'm trying to show, that the gas started accumulating in the center where there was more gravity. And once that started happening, the cloud of this center bulge, which was being created by the cold gas or cooler gas, uh, that basically became unstable instantly. And this is all happening because of the findings using the simulator, the space simulator. And when the central portion, which is very thick gas cloud, collapsed or became unstable, collapsed straight away into a very large black hole. So basically, this cloud bypassed the processes of stars. The star has to get formed, then star has to burn for million years or billions of years, then the star will collapse into a black hole. So this whole process, because the gas was colder at that point in time, it bypassed the further processes and straight away transformed into a black hole. And this black hole, which was created because of this process where the gas collapsed, the cloud became critical, became unstable, and collapsed directly into a black hole, had a starting mass of up anything between 80,000 to 100,000 solar masses. So the starting mass of the black hole falls into the category of supermassive black hole. So that means these black holes which were formed in the early ages of the universe were very large, and they were in the category of supermassive black hole. And then if you start at this point and then continue the journey, then you will have straight away a good candidature to become an ultra massive black hole that we see in the center of the galaxies. So I think this simulator proved the point that the early part of the universe, there were a bypass mechanism where the large chunk of material collapsed directly into a black hole without forming stars. And these early black holes, as we call them primordial black holes, were very large, and they had a advantage, the starting advantage, because they were already very large and they were in the category of supermassive black hole, not like the usual black holes that we see every day, and these are called stellar black holes. These are already very large, and then if you start at 100,000 solar masses, you will become billion or millions of solar masses over period of time. So you have an advantage, early advantage of being large, and that is when today when we see these ultra massive black holes, we can then calculate using our formulas of physics, and then calculate everything backwards and prove that this would have been the case. So this simulator shows that this is the nature of the early part of the universe, and this is how the early part of the universe would have formed. And this would have also created huge gravitational waves. So right now the scientists are trying to search the evidence of these huge gravitational waves which would have been created by the formation of these supermassive early primordial black holes. And the search is on, and for the if these gravitational waves are found, then the evidence will also be available to prove this theory, because right now all of this is being done using the simulator, and therefore the scientific community basically look at finding the evidence to whatever theory they propose. So I think this is something which is very interesting, which has recently happened, that we have been able to sort of predict the nature of the universe during the early part of the formation, and how large black holes would have got generated without going through the life cycle of star formation, and the cloud can directly collapse into a very, very large, very heavy black hole itself, which is the right candidate to become ultra massive today that we see in the center of the galaxy. So friends, what do you think about this latest development? And if you have any opinion, do send in your comments, as you know that I respond to each and every one of your comments. And for today, I like to say goodbye, and if you have any suggestions, I will look forward. But for today, I would like to say goodbye, and I will catch you again in the next one.